Welcome to Study Loop.
Let's evaluate the given integral. Since the numerator has degree larger than the denominator, let's go ahead and do polynomial division. X to the fifth over x cubed, that's x squared. So let's go ahead and multiply that out. Then you subtract, and you're left over with negative x squared plus x minus 1. And this will be our remainder because x cubed does not go into x squared. So coming back to the original problem, we can rewrite this integral. Our quotient was x squared. That's from up here. And then we had our remainder. So let me go ahead and pull out this minus sign. So we have a minus. Actually, I'm going to take a step back here. I'm going to just write this as a plus. Plus our remainder. X cubed plus 1. Okay. And then now I'll break this into two integrals. And for the second integral, let me just pull out this minus from the x squared. So then I'll have x squared, and then we have to change the sign on the other terms because we factor out a minus sign. Also, there's a formula for x cubed plus 1. This is an expression of the form a cubed plus b cubed, where here a is x, b is 1. And there's a formula that says this is equal to a plus b, a squared minus ab plus b squared. So using this formula, we have x plus 1, but then we have x squared minus x plus 1, and we can see that there's some cancellation here. This quadratic term cancels nicely with the other. So we're just left with integral x squared minus, so I should put a dx there technically, minus integral 1 over x plus 1. Now for the first integral, we can just use the power rule. That's x cubed over 3. For the second integral, if that plus 1 is bothering you, feel free to go do a u sub. Here you can take u to just be x plus 1. Then you have natural log, absolute value, x plus 1, and then don't forget the constant c of integration. And that's our answer.